Hello everybody, welcome back to my channel Pharma Agile. This is Devi Sarojini. In last video I had discussed about different types of HPLC peaks like good peak, peak tiling, peak fronting, split peak, shoulder peak, absent peak. In this video I will discuss about broad peak and negative peak. If you are watching my channel for the first time, don't forget to like, share and subscribe. If you have any query related to pharma, please feel free to comment me. I will give you a video on that. In this video I will discuss about broad peak and negative peak. Let's discuss without any delay. Let's start the session. Broad peaks in HPLC, characterized by a lack of sharpness and a wider appearance, can result from various factors like column issues, mobile phase problems or sample preparation issues, and can affect the accuracy of your analysis. Column related issues means like column deterioration. An old, worn out or damaged column can lead to poor separation efficiency and give broad peaks. Column overload. Column overload means injecting too much sample into the column can cause it to become overloaded, leading to peak broadening. Poor column packing. If the column packing material is not properly packed or if the packing is uneven, this can lead to peak broadening. Column leak. A leak in the column or column fittings can cause peak broadening. Column temperature. If the column temperature is too low, the peak may appear broad, and increase the temperature may help to sharpen it. Next one, column length. A longer column can also lead to more peak broadening. Second one, mobile phase issues. If any improper mobile phase composition is there, then also peak broadening occur. Using the wrong mobile phase composition or pH can lead to broad peaks. Flow rate. A deviation from the ideal flow rate for the column can cause peak broadening. Dirty mobile phase. Impurities in the mobile phase can also lead to broad peaks. Mobile phase temperature. If the mobile phase temperature is too low, the peak may appear broad, and increasing the temperature may help to sharpen it. Mobile phase additives. The concentration of additives in the mobile phase can affect the peak shape. Next one, sample related issues. If any sample related issues are there, then also peak broadening occur. Sample matrix effect. The sample matrix can interface with the separation process, leading to broadening peaks. Poor sample preparation. If the sample is not properly prepared or if there are impurities present, this can lead to broad peaks. Sample injection volume. Increasing the injection volume can result in peak broadening. Sample solvent mismatch. A mismatch between the sample solvent and the mobile phase can distort peak shapes. System related issues like dead volume. The diameter of the capillary between the column and the detector can have a large influence or peak width. Dirty inline filters, frits, capillaries or injectors also be a problem. This can lead to the broadening of peaks. Leaks. Small leaks between the column and the detector can have fatal consequences for the quality of the chromatogram. Detector response setting. A slower response setting can reduce noise, but it also results in the peak broadening. Temperature gradient effects. The temperature is lower at the center of the column than near the column inner walls, which can cause peak broadening. Next one, negative peaks. Negative peaks in HPLC chromatogram, where peaks dip below the baseline, typically arise from differences in refractive index, absorbance or system issues like air bubbles or improper detector settings, rather than a true negative absorbance of the analyte. Refractive index detection. Water peak. When using RI detection, the water in the sample elutes with a lower refractive index than the mobile phase, causing a negative peak. Blank injection. Injection in the mobile phase can also result in a negative peak due to the RI difference. UV visible detection. Mobile phase absorption. The mobile phase might absorb more light than the sample components at the chosen detection wavelength, leading to negative peaks. Reference wavelength also can cause the negative peaks if the reference wavelength in a diode array detector is set too close to the detection wavelength, or if the reference wavelength function is on, it can cause negative peaks. Next one, air bubbles. Air bubbles in the system can create pressure fluctuations that can cause negative peaks. Column drift. Some baseline drift is normal over time, but a sudden or persistent negative peak could indicate a problem with the column or system. Sample solvent differences. If the sample solvent differs significantly from the mobile phase, it can lead to negative peaks. Some system issues also cause negative peaks like back pressure and detector problems. Back pressure. Changes in HPLC system back pressure, such as from an injection valve actuation or an air bubble, can cause negative peaks. Detector problems. There might be an issue with the detector itself, such as a problem with the polarity or physical connection determining the polarity of the detector signal causes negative peaks. This is all about different types of peaks in HPLC. In part 1 I had discussed about good peak, symmetrical peak, peak tiling, peak fronting, split peak, shoulder peak, absent peak. In this video I had discussed about broad peak and negative peak. I hope you understand. For more videos, please don't forget to like, share and subscribe. Thank you.